now what? Yeah, that's good. So this becomes a challenge. Now I can mess around. I could, this time I'll take a prefix from here, something middle from here, and some suffix over there. If there are more, it's, I can distribute them in strange ways, right? So it's unclear how to go about counting this.
So how are you deciding where to draw the green line?
I was just playing around, saying, okay, let's see how to get 2 copies. Let's see how to get 5 copies. Let's see how to get 7 copies, because that's what the problem is, right? Somebody's going to give you a number, and you're supposed to build something that has exactly that many copies or subsequences of the. If we don't know how to do this even for small example value, we're not going to get anywhere, right? So we need to understand, So we need to understand this problem, and hence this thinking. Does that make sense?
Yeah.
Or maybe another way to ask is, do you know how to create a word that has exactly 2 copies of satellite? And it turns out it takes a little bit of time, although it's not hard.
Just 2.
Sorry?
Just 2.
Just exactly 2.
My thought is you write SS and then Adelaide.
Right. Very good. Hey. Yeah. SS would work, but so would many other characters as well, right? But not all of them, right? Which ones would work and why? So it seems that the only thing that would work are things that are unique, right?
Yeah.
There's only 1 copy of it. If you want, you can put it over there so that it's easier.
I can see it.
Well, you need to read this problem first.
Which problem? One on the left, right?
One on the right. Yeah.
On the right.
I can turn it on.
Yeah.
It does get hot, that's like turn them off.
Well, it gets hot.
So you're absolutely right that there's a simple way to get 2. But what if I want 17? Or some small number that's manageable but yet not.
Yeah, because I was thinking like you could just keep adding S's, but like the problem bounds, like it's the
Right.
output is ridiculous and it's like 10 to
Correct.
18. So you can't just write 10 to 18 S's.
That's right. There's no way to write 10 to the 18 times because we'll run out of time. Yeah.
And it may not even be possible to get some number, right?
Yeah, so, well, according to them, every number is possible. They claim
Every
so.
number is possible in that range.
Yeah.
Interesting.
Well, yeah, they say that, where do they say?
In the output.
It can be proven.
It can be proven that under the given constraints, a solution always exists.
Huh.
Yeah, proof could be interesting as well. But I'm still trying to get a grasp of this problem.
For the smaller problem,
Yeah.
would it be safe to say, like, initially you have to pick 4 letters?
Right.
So we look at that very first instance of SATE.
Yeah.
You do 4, choose some number
Yeah.
between 0 and 4.
Mm-hmm.
And now after that you have some remaining. Now you do 4, choose.
There. Yeah. So that's correct. But again, maybe this is too simplistic, right? I
Uh-huh.
mean, maybe this doesn't generalize to general problems. Does that make sense, Mimi? Are you keen in?
I don't understand how the second one works.
How the what?
The
Second example?
Yeah. So which makes me think I don't understand it.
Right. So you're curious about how this gives you 2?
Oh, yeah.
You want to explain?
So they have like the instance of the word satellite, which by itself is one, but
Right,
they
but
add
she wants to know how she got, how
So
you
the
get two.
substrings are different, like you're able to cut it, so you get two substrings and have.
How do you get two
Yeah.
substrings? That's the question.
Yeah, so it's not substrings, it's subsequences.
Oh, okay.
It
Subsequences.
doesn't have to be contiguous.
Oh,
So what they do is they get two by taking the first S.
Yeah,
They
there are
skip
two
the-
S's there.
They skip the next S and then they just take
Oh.
satellite. Yeah.
okay,
You got it?
yeah.
Okay. So, depending on which S you pick here, you'll get a different copy of the word satellites, and so therefore there are two there. Clear? Okay.
Can you see the third one?
Is that a third one?
Yeah.
Okay.
Oh, yeah, so.
Same idea.
I didn't even look at this example, so at least they had this, right? So, why doesn't this generalize? This doesn't generalize because this number seems too large. But I could do other tricks. I could, what if I had 3 copies of S and 4 copies of A, and so on, and then the rest I leave it as it is. What happens here? How many do I get?
So many.
12.
How many?
4 times 3?
Yeah, I'm thinking maybe 12.
Is it 12?
I think it's
For
12.
each of the S's, you
For
have
each
four-
one of the S's?
You have 4 possible A's.
I get one version of the word, and for each of the 4 copies of A, I get another version of the word, right? So it's 12. So therefore, since multiplication works, could I do something here?
But just multiplication isn't enough, because you have a string of left 5,000, squared would just be,
All right, so I know that this guy here, this one here, the I here, these are unique. So those I can make as many copies as I want, right?
Mhm.
So that would reduce the problem quite a bit. So if I have to multiply 3 numbers, and if I make them 10 to the 6, roughly 1,000,000 each, I can make.
No, you
10
can only make them up to 5,000 in total.
Where's?
The output says has to be at most 5,000 letters.
Ah, okay, right, okay, I didn't see that, sorry, yeah. Yeah, so 10 to the 6 is not enough, so I have to do more. Okay, so with 3 I can get it down to 10 to the 6, that's clear. Now, I could play with the 2L's. Now, if I did this, how many copies do I get?
4 choose 2.
You mean 3 choose 2?
Oh, there's only 3 of them? Oh, yeah, sorry,
Right.
3 choose 2, yes.
So I could now produce more numbers there.
Mhm.
So if I put, just for the sake of argument, if I put in 1,000, I get 1,000 choose
Choose
2,
two.
which is roughly of the order of 1,000,000 already, right? That's not bad, so you're cutting it down quite a bit there. So with the L's and the S and the A and the E, can I now narrow things down? Am I still off the mark? So if I do 1,000 here, 1,000 here, 1,000 here, and 1,000 here, I'll get, between these 3, I'd get a 10 to the 9, and for this I would get 10 to the 6. So I'm somewhere near in the 10 to the 15 range.
It's
So I'm getting close, right?
Yeah.
Okay, so what can I do with the other 2 to the TE, which is nicely separated up? Is everyone clear about what I did with the S, A, I, and L? Okay. All right. Any thoughts on what to do with the TE? So again, over here, I could try some simple things like the following. What if I just make multiple copies of this E? What happens then? The rest is whatever. So how does this impact us? You can see here that if I don't mess around with the word dramatically, right? If I keep the order of the letters the same, but all I do is increase the number of copies, this works exactly the same way as S at A. Isn't that right? If all I do is the following, so let me now so all I'm doing is I'm making lots of copies of E. Okay. And I make a bunch of copies of L. Then a bunch of copies of I. Then I keep that as this. So, am I not getting closer? So here I'm getting let's say 1,000 or even a little bit less is fine. I get another 1,000, 10 to the 6, right? Another, and this also I can do the same, right? So 1,000, million, between these two another million, over here another at least 500,000 at least, and here another 1,000. So 1, 2, 3, 4, 5, and then I'm now at 7. So I'll do the same over there. So again, over here I could expand these out, I could expand this out, expand this out. Why is this not going to work? What's wrong with this approach? Are you with me so far?
I think so. So is it not possible to have a string given to you where, for example, you have SATEE, TTEE? Can that happen?
Yeah. So each one I'm going to put in a whole bunch, as many as I need.
Right. But is it always going to occur like that? Can you not have repeating ones where, you know how you had the S followed by a bunch of A's? The
Yeah.
last line? Can you not have 3 S's after the 4 A's?
It's up to you to design. You can do whatever the heck you want.
So that will also change.
No. So look, this is a problem of design. It's not a problem of counting.
Okay.
Right? You're only given a number. Somebody will say 4 million blah 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 733,822, and your job is to concoct a sequence that has exactly that
Okay,
number.
got it.
Okay.
Okay.
So I'm saying, first of all, I need to convince myself I can get even close, right? After that, I can worry about some other nonsense, getting it all right. The problem was with 10 to the 18, I didn't even know how to get close. Now, I'm showing you a way of getting close. Or at least I'm claiming I'm showing you a way to get close. It remains it's up to you to figure out, to tell me whether you're convinced or not. And remember, I can make this, since there are 1, 2, 3, 4, 5, 6, 7, 8, roughly 8 stretches, I can, since I'm only allowed 5,000, I can make each one of them roughly 600 or so, let's say, right? So if I make 600 S's, 600 A's, 600 T's, 600 E's, roughly I'll get to the required number, or at least that's what I'm claiming.
So in this case, since you're expanding every letter out, we have to pick one letter from each group.
Correct.
We have to force it to follow this.
Correct.
I think this looks fine.
This looks fine. You think that any number that they give you, you can now do it?
Oh, I'm not saying that. All I'm saying is-
I'm asking where is the problem? What's wrong with the strategy? So, the strategy is great in the sense of getting close enough to the number. What is my next hurdle?
But is there agreement that you have to pick one letter from each group? So
Well,
counting the
this is my
subsequent.
strategy. I'm asking why is it wrong? Why is it not enough for me to solve the problem?
The number they give you, might not be a product of like the.
There you go. So why would it not be a product? Because you have things called prime numbers, right? So you could get a prime number close to 10 to the power 18. What are you gonna do? Right? So this works for nice factors that are roughly close to a 600 or so, right? If your prime numbers are less than 600, I can do this pretty well. Is that clear? So the biggest hurdle, it turns out, is taking the number they give you, factorizing it, which is what you have to do first, and making sure that each of the factors is smaller than, say, 600. Or maybe even a little bit more is okay, I'm not really sure. Did that make sense? So that's where the bigger hurdle is, right? Prime numbers are, well, factorization, by the way, there are algorithms for it, and you can plug those in. But there are two major hurdles. One is that maybe it just doesn't factorize. And secondly, even if it factorizes, maybe the factors are just so humongous that they don't nicely fit in like this. What if the factors themselves are more than 5,000? Then you're also in trouble. Okay, so these are our constraints. So first let's see what to do with factors that are too large.
When you say factors that are too large, it means you can't minimize it anymore, so that would be a prime number too? Because if not, you
Yeah.
could factorize it more.
Yeah, well, so problem, what is a factorization? So there's a theorem that says that you can take any number and write it as a prime factorization, which turns out to be, first of all, it's also possible that you get too many prime factors, right? It's possible that it's a product of too many numbers, which is also not. But you can say it's 2 to the power something, E1, 3 to the power, E2, 5 to the power, E3. So these are all your prime numbers. Okay, so this is called a prime factorization of your number. This can be done, it exists. Any number can be written in this form, where these guys are all your prime numbers. Okay? So typically whatever number they give you, you'd probably start with this. What I'm saying is that this prime number could maybe be too large. It's possible that this itself is a prime, in which case all you get is the same number itself. You don't get anything else, right? If you're looking at 17, there is no way to factorize it because it's a prime number. It's just 17 to the power 1. That's all you have, right? Because it itself is a prime. You with me so far? So therefore, one problem is it doesn't factorize. The other problem is it factorizes into numbers that are too large. I don't know a good prime number that's larger than 5,000, but let's just assume that 5231 is a possible prime number. if this is one of your factors, you're lost already.
Isn't it not that bad because
Sorry?
if it's prime, the next closest number that's not prime, you would just subtract one. And that would be
Okay,
the next
so
closest number.
if you subtract one, then how are you gonna get to it?
Um,
Yeah.
Adding might be easier, so for example, the
Uh-huh.
last T.
Okay,
last
now we're getting somewhere interesting. So you're saying, adding is easy, but
Easier.
how do you do that? So let's say that I want to, I don't wanna reach n, I wanna reach n minus one. How are you, and then, let's say I know a word that has exactly n minus one copies of this word. Now tell me how I'm gonna get to n.
Well, here's a dumb approach, the last E,
Uh-huh.
I just add one more E.
Does that do it? No.
No?
Mm-mm. It gets multiplied. We just told you that, right?
Oh, shit, okay.
Maybe you need one number that you don't multiply, you
Uh-huh.
can only add one.
Ooh.
Wait, what did you say?
He says, don't make copies of the last TE, for instance. And that way if you just add extra E's, it just becomes added. Is that correct? No, that's not correct.
It adds to itself, like if it was x before, then now it's 2x.
Right. Right. If you add an S there, it becomes 2S, yeah. You were gonna say something? So I really don't know how to add, actually. I've been breaking my head over this. I haven't figured it out. Maybe you guys can tell me. Or what you can do is make sure that your So I could not solve this problem, and instead I tried a different approach. If you guys have thought this through, we could discuss that.
So in the example they showed us,
Yeah.
it went from 2 to 3 by just adding one more S, right? So we are only multiplying when you have one repeating sequence followed by another repeating sequence.
Correct.
If you don't have a repeating sequence that follows, then you're
Right.
only adding it by one.
So the question is, how do I go from 5,000 to 5,001? Now tell me.
So you have to look at, so for example, where you have the TE, where both T and E are not repeating, if you do TTE, it increases by one.
It's not true. You mean over here or over
Yeah.
there?
No, there.
Over here.
Yeah.
So if I put a TT, now the number of copies of satellite is 3 times 4 times 2 times whatever this is times some number here times that. So it's multiplied, it's not added.
What if we had the entire work?
Sorry?
What if we had the
Ah,
entire work?
so that's why I wanted to start with this. That's why I
Okay.
wanted you to think about this. Because there, it does throw a monkey wrench into all our calculations. So this is a good way to get close enough, that's pretty clear, right? So what if I made 2 copies, right? What if I did this whole thing and then I start again and make whatever I want over it, that I wanted here? Would that work? But then, how do I now figure out the count? No, it's nasty.
What if you just put an S somewhere?
Sorry?
What if you just put an S somewhere nice? Does that make it better?
You mean S somewhere, like
Yeah.
here? It's not gonna do anything for you.
How does that help?
No, I'm saying like, what if? I'm saying like, this
Yeah.
is a possible idea. I don't know if
I
it's
know,
good or not.
I know, but this way I was trying to go from the primitive, saying, okay, if I can construct any number I want, then it's solved. Or if I cannot, then I need to know what what I get from simple operations. So, really what we're asking is the following. If, let's say I have a number of occurrences of the word satellite here, and let's say I have B number of occurrences of the word satellite here, if I put those together, what do I get? It's definitely not A plus B, it's not A times B,
What if you
it's
put
something weird.
S before the last A,
Sorry?
an S before the last A. So you see what the A's are?
Yeah,
You put an S.
over here.
Yeah.
Before the
Before the
fourth
last
A.
A. Wouldn't that be called a satellite?
Like that.
Yeah.
Hmm. You think it'll help in what way?
It only has one satellite, right?
One more satellite.
There's no other possibility.
Wait, so now I need to rethink everything here. So you were saying what? Maybe I'll just use this board. Alright, so you're saying I have a bunch of S's, right? Oh, no, sorry. I have a bunch of S's, and I have a bunch of A's.
Actually, you could add any number that you want.
Sorry?
You could add any number of satellites that you want like that. Pretty sure. If
Any
you want to
number
add
of-
three,
say that again?
you could add any number of satellites that you want in this way.
Oh.
If you wanted to add three, you would add it for the 1, 2, 3, third A, and then you get 3 more satellites. Only if there's no more S's anywhere else.
No, but all of these get multiplied, so I'm not really
Oh.
sure, I don't quite see where you're
Okay.
going.
I see.
That's why I wanted to be careful. I think what you're saying might work with the I, but I don't see how it'll work for anything else.
How do you get more than one satellite with the? Well, let's
No, I
table
meant
the second
that
idea.
just before the last I here, just before the last I here, I could add an L. Then what you're saying may actually be true, is it? Is that right? No, it's true, it's multiplied
Yeah,
by
yeah.
all those guys on the left, so it's crazy.
So you could do this in 1 second.
Sorry?
Add 1.
I still don't know how to add one to a large number. I can see how to add one to a small number.
So if you do 1S, how many satellites?
So
in this
imagine
example?
that I've done some work, okay, I don't even know what it is, and I have this many number of the word satellites. Now, do you know how to add one to this? Actually, I don't.
And you're saying if you just add the word satellite to the end, it doesn't just get added by one?
Right, so just look at this example.
Yeah.
How many satellites are there?
Let's say two. No? Oh, okay, so you could pick this S and the rest of. okay.
Right.
Yeah.
So that's why I was saying, if I gave you two words, two long words, one that has F number of copies of the word satellite, another that has G number of copies of satellite, if I put them next to each other, how many do I get? It's not F plus G.
No, it's not.
So what is it? And the answer is that it's a little more involved calculation.
It would be times n minus one, no? If n is the number of letters.
Sorry?
Would it be times n minus one? Because for every single letter on the first one,
It's a lot more involved, I'll show you,
Yeah.
yeah. Any thoughts before we? So, you're still pursuing your idea?
No,
I was
I think
intrigued by
so.
that idea, but you've gotten stuck there, right?
Yeah,
It's unclear, all right, fine. So let's move on to something else then. All right, so the other thought I had was, what if we change the problem a little bit so that maybe we still need better understanding of the problem? We're still far away from quite figuring out. We don't know how to add to the count, so we have some serious challenges. So, question is, we need to understand what it means to, well, there's something that we are missing. So one thought was, what if I gave you a string and I say count for me? Do you think this is an easy problem?
Like count the number of subsequences of satellite.
Yeah.
I
And
thought that was the original problem, that's why I asked you that first question.
he told you several times, now you're fine, right?
Yeah, yeah.
Okay, yeah.
I can do it.
Yeah.
I don't know how efficient you have to be.
I was telling like Ricky at the beginning, like
Sorry?
I was telling Ricky like at the beginning, like if it was just counting, like
Yeah.
I think maybe it might be possible depending on how big the
So
string
what
is. It might
approach
be,
would you use? That's
I was
the
thinking of
question.
using dynamic programming.
Yeah, good. So it's clearly a dynamic programming problem. There may be other ways, but I don't really know. So how do we do this with dynamic programming? What is the, is there a recurrence that's clear in your head? Yeah?
Yeah.
Wanna write it down?
Like me on the board.
Yeah.
Yeah.
Yes. You want me to move this desk away?
Yeah, sure.
Index in the word satellite?
It's hard to straight.
Yeah. Okay.
And then I was thinking that if I is greater than that length, I'm just gonna say S1, and J is greater than
Y is greater than. Well, forget about special cases, just write the main one.
whichever case.
Yeah. Yeah. Let's focus on the main thing, right? The special cases we can always add and yeah, but make it cleaner. What's happening? Why is it going? Alright, so what's the main if condition?
If the
S of I equals S, yeah, target J, yeah, correct? And you mean I minus one?
I'm starting with the suffix. Cause you're probably, like, your initial call probably is, like, you start with the lengths. Yeah, mine, I'm starting at 0.
Ah, okay.
Yeah. So like my initial call would look like that. So I move up. And then. Yeah, so we have some counter there for like the actual answer, and if they're equal, we have the choice of saying that like that character in S1 is gonna be part of the subsequence.
Mhm.
So you add that, like, however many ways you get out of that. Otherwise, you can just, move your string forward by 1 without actually, like, including this character, I think.
Mine was much simpler, recurrence. Let me try writing mine. I wish I could move this.
You
copy.
can actually,
What?
you can move it,
The
The
whole
whole
thing?
thing.
you can move it to, yeah.
Yeah.
I can, like, for you, just.
You can maybe shrink it.
Can you move it?
Sorry?
Does it say shrink it? Maybe so you have space.
No.
You can just pull the corners.
The corners, the actual four corners of the box?
You just pull?
Yeah.
Okay, yeah, that's fine. Okay, so what I had in mind was the following. Here's my, here's the string I'm given. Let's call this S. And here's the word satellite, which I'm gonna call as T. And I am saying, I have a count. So C of I comma j is the count of only a part of the target, namely 1 through j, in the original string 1 through I. This is what I'm going to write the recurrence for. Okay. And I'm saying that this here turns out to be the following recurrence. It's simply going to be I minus 1j if something happens. Otherwise, it's going to be I minus 1j minus 1 plus something. And I have to kind of figure that out. It'll come in a second. Yeah, plus C of I comma j. Let me explain what this is. So this would be the case if
Isn't it I minus 1? On the most bottom
I
one.
minus 1, yes.
It's the same thing.
Yeah, it's good.
Okay.
You just always do it backwards.
I've always done it like
Is it the same as what he's written?
He just always does it backwards.
that. Yeah.
I
He
see.
likes to make fun of me.
So this is if T of j is the same as I, S of I. So this is what's happening. You're looking at this particular character, that's the j character. We're looking at some character here, let's say, let's actually match them here. That's the I character in this string. We're saying that if these two characters match, then I'm going to be able to count the number of occurrences of all of this by figuring out how many copies I have of one less. That's the j minus 1 in whatever is to the left of this, and add to that how many copies of the whole thing I have in the string ending here. Does that make any sense? Yes, Rosalie.
May you reiterate that last part where you were
Repeat it one more time. So there are two possibilities. So one possibility is that this character is the same as this character. Okay. If it is, then so imagine that you're looking at the word S A T and then this guy is an E. All right. If this here is also an E, then what I'm going to do is I'm going to count how many occurrences of SAT there are to the left of this, and I'm going to say, oh yeah, I can add E to it and I get SATE, right? So either that character matches or it doesn't. If it matches, then I will count how many times I get SAT and then add the E, so that's I minus 1, J minus 1. Right? Because I'm only looking at one less from this target, and I'm going to look at left of this, that's I minus 1. And then add to that, how many occurrences of SAT are already there, to the left of it. And that's, to the left of it, how many are full copies of SAT. So I'm adding both of those. Yeah, I'm sorry, I couldn't wrap my head around what you wrote
Yeah.
there.
Ricky has the same problem, because like I've just always implemented DPs, like starting from the beginning and then going to the end, but most people do it the other way around.
Yeah, so you're writing the recurrence, the recursive version first, and that's how you're doing it. Okay, fine. So so what this tells me is something nice. If I now imagine a big table, remember your dynamic programming typically has a table, right? Where this here is the string S, this here is the string T. Then what it says is that this value here depends on what? Depends on the previous row. Let's use a different color now. It depends on the previous row, same column, right? That's this guy here, or it's previous row, previous column. It depends on these two things. You have to add those two numbers. If this matches that, otherwise you just take that and don't add anything. Okay? So here was a thought I had, namely, you start from there, put that number n over here, and then start to cook up this table.
Huh.
Okay? I didn't succeed.
Yeah.
I didn't say I succeeded in it, but this was my thought, saying, okay, shouldn't I be able to put in whatever numbers I want and then make the whole darn thing work? Maybe. Maybe. That's where I was. So remember, in the end, your count is going to make a path. Right? Because you're dynamic programming, you walk back and you get this path. And the path is going to look something like this. The path is going to, let's use a different color. We'll start here and we go diagonally sometimes, but then mostly it will go, it will, yeah. It'll do a lot of this way things and then diagonal, this way things, diagonal, something like that. That's, your traceback path should be, did I get that right? Yeah. Why is this going horizontal? Shouldn't this be vertical? Was that right?
That looks right. If they're not equal, you can just take whatever you previously had. If they're equal, then you have a choice of taking this letter or not.
Right, but what is the role of this guy here? That's what I know. Because most of the time you're going to be going horizontal. So what are those values telling us? Are they going to be the same?
Like the ones directly to the left?
Yeah. Are they going to be the same, or is there any relationship there? Shouldn't that be playing a role in the recurrence?
It's which can you label S is the original string?
Yeah.
T is the pattern? Okay.
Right. T
Satellite.
is your satellite. Yeah.
Yeah. So T is a row.
So if it's on the same row, then you're matching the same substring. And since the last character didn't match, this number should be the same as that number. So why isn't this IJ, it looks like this should be the same as this, isn't it? If it doesn't match, I mean. So look over here. If this doesn't match that character, right? If whatever there is over here doesn't match that character, isn't it true that, whoops, what happened here?
The count doesn't change, you see.
So shouldn't this be the same as this guy?
This is a string. T. would have labeled it the opposite way, but I don't know.
Meaning, well, this is your i's and these are your j's, right?
Yeah.
But, this is what made sense when we wrote down the recurrence, but over here somehow it's going to be the way around. It's going, so I'm saying maybe this is the same as ij minus one,
Because
or should it be maybe
you
maximum?
have at the count of t1 to j,
Right?
and then here you have I is equal to t.
Yeah, so that's a mistake. Yeah.
Can you just flip
J is
S
in
and T in the grid,
Ah, okay.
and then that fixes everything?
Yeah, yeah. But instead, let me just fix this, right?
Yeah.
You're saying just,
I is still the row, but it means the S.
right. You're saying T and S. Is that right?
Yes.
Yeah, but then your paths are going to be going mostly vertical. Occasionally they'll do a
Uh-huh.
diagonal thing, right?
Yeah.
They can't be going horizontal like that.
I don't know, only like diagonally, yeah.
Yeah, so I have to redraw this, something is right, something is wrong there, let me just redraw this. I is in the, so really the rectangle looks something like that. Here's your S, here's your T. This is what gives you the ith row, and this is what gives you the jth column. And we're saying this entry will give you the answer, but any entry here, ijth entry is going to, it's going to depend on, okay, fair enough, yeah. You're right, I just screwed up in there. So this depends on either this or this,
Yeah.
right?
And that makes sense.
Yeah. So typically from here, you're either gonna get lots of that. You'll get a path going like that. Now, the point I was trying to make was that if it doesn't match, then you're just going to get the same value as above you. So you can just keep those values. But if it does match, then this guy is really the sum of that and that. And
Yeah.
so I could divide this.
But then you have to pick where to divide things and what these two values are.
Right, but my point was not to figure that out, instead to see if I were to put numbers here that were roughly consistent to this, consistent with this recurrence, can I fabricate this number? Can I fabricate such a string?
Oh, you're saying now you have addition, this
Yeah.
helps you.
Yeah. Because I could fabricate what I want. But first of all, if I just gave you a bunch of numbers that are consistent with that recurrence relation,
Mhm.
can we now fabricate the string?
Yeah.
So if that is so, why can't I? So now, before I came
But
to class, I was trying to see.
don't you have to fabricate the last row entirely?
Not the last row, the last. No, I just need these characters, which means I have to know where the diagonal happens. Okay. For all other places. Okay. So first of all, if there's a diagonal here, what it tells me is that this is the word satellite, so this was an E, so therefore this here is an E. Right?
It matches up, yeah.
So it fixes where my E's are. Well, at least it fixes the one of the E's, is it? Okay. And then I would know where the next T is because I know where the diagonal is, and so somewhere here is the T. Alright, but that's not going to be enough. And the point is that between this T and this E, I just want to make sure there are no other E's. If there are, then it could mess me up, that's all. So from here, I was trying to do, let me now erase something here. Let me erase the board. So let's say let's try a simple thing where, let's say we have 7. Let's say we want to concoct a sequence with exactly 7 copies of satellite. Can we now do this? Using this approach. Because if we do, then it doesn't matter how large the number is, we can sort of work our way backwards, right? Does that make sense?
That makes sense, but I think no.
You think I'm gonna fail?
Because there has to be multiple ways to do this, so then you have choices.
Right, so we know that we have a limit on the length of the sequence, so whenever possible, we want to divide it equally, so when I have choice, I can pick. That's my point. My point was that if I want 7 here,
Okay.
right? So most likely, let's say, so do we know an answer, possible answer for getting 7?
Just 7 S's.
So just 7 S's. All right, fine. So 7 S's. So that means this last one is just going to be an E. So therefore, I just have to add these 2, and that's what I should get. Right? So here it's too easy. I can do it as 6 and 1. But instead, what if I did 3 and 4? Is that even a possibility? That was my question.
Yeah.
So if I can do 4, if I can just pick my 2 numbers and concoct this, then I'd be done.
Well, that 4 is dependent on the one below it.
Right. So this is obviously an E because otherwise I can't do the split. That's an E. That's the next one is a T. And
So now we know below it has to be a 4, right?
over here.
Yeah.
Right, because it doesn't match.
Uh-huh.
Yeah.
So it'll just be the previous row. Because nothing else matches, it's just whatever it was before.
Right. Fine. But now the question is, where is that T that matches with this? No.
Oh, but there's
there'll be
another E.
multiple ones, right?
Yeah, there's another E.
No, so I'm trying to answer this question, can I concoct something where this is 4 plus 3 instead of 6 plus 1, which is what this bunch of S's at the beginning would give me, right? So I want to build a different sequence, and I'm asking, can I do this? If I'm able to do this, then I can manage any number. Now, what is that 4 and 3? The 4 and 3 are these two guys. That says there are 4 copies of the word with one, that we need 3 full copies of the word satellite to the left of it, and we need 4 copies that end here. Right?
Wouldn't it have to be like the right number has to be bigger than the left?
Yeah, you're right, sure. Yeah. So, therefore, yeah, can I do 3 and 4 or 2 and 5?
I'm not
Yeah.
100% sure what follows, but could you do like 4 E's at the end and then 3 C's?
Well, if we can understand what these numbers mean, then it may end up being what you're asking.
I don't understand.
That's fine. I'm also struggling here. Haven't spent enough time thinking about it. I don't have the answer.
The main idea is instead of doing DP where you count these things, now go backwards, see
Right.
if we have a final thing, how can we rebuild it? So the final answer, like let's say the DP is 7, we want to get to 7. So we want to pick 2 numbers that add up to 7, and we just chose 3 and 4 arbitrarily. Can we continue doing this until we have a DP table?
Right. If this was 6 and 1, this would exactly match what you did here, right? Is that right?
It would just be a bunch of E's.
No, it would be 7 and if it had been this 3, 4, 5, 6, 7, and then this, what would my table look like? For this particular sequence S, right? If S is equal to this is my S, then my table would look like zero here and 7 here, right?
I think that makes sense.
Because you don't have the entire word satellite
But yeah.
before this, right? So that's going to be a 0. In fact, all of these are going to be 0, right? Because you don't have a copy of the word. This will be 7 until we get all the way to the end here, and then it'll go 6, 5, 4, 3, right?
Yeah.
Because these are all S's, and then you have the word satellite. Is that clear? That's what your table will look like. Now I'm saying I want to modify this table instead of trying to work out my string. Okay, let's do something simple. Let's try 6 and 1. How can I get 6 and 1? In order to get 6 and 1, this better match the E. Well, it's still matching the E. So this is still going to be an E, but I don't know what that's going to be. also I want a complete word satellite before this. Right?
Mhm. If not, you're not gonna get the one.
Otherwise, I'm not gonna get that one, exactly.
I'm not convinced that, you know how you showed us the 4 times 3, 12? I'm not sure that will come in this.
It will come in, so that's why I'm trying to see, what is preventing me from working it out this way. Whether there are constraints on the kinds of numbers you put in that end up here. If there are no constraints, I can put in whatever I want happily and create the string, right? And then I'd be done, because this would be a completely reasonable way to concoct the string.
Wouldn't 6 and 1 be 6 S's and then 2 E's at the end?
Right, but then it's not 7, so what's wrong? Because now
Shouldn't
it's
it be
6
then
times,
12?
then it becomes 12, so why is it not showing up? Why is it coming up this way? So that means that this here is not 1, is it?
It can't be 1.
It's not 1 because you have 6 S's, so it was 6,
Yeah.
not 1. That is the problem. So that means there are constraints as to what you can put here. If we can understand that constraint, then we can create the sequence. What is that constraint?
Maybe it's not possible to get one. Maybe it's just
Maybe, yeah. That's possible.
So 43 might be more reasonable than that means.
That
So that
constraint is
means
dependent
that-
on the previous row and column.
Sorry?
That constraint is just the same thing we're doing at the last one, and this just keeps going back until we have everything, so
Right, so that's why I don't completely understand. I was stuck here and I never made progress up here. Okay, so. Wait, what if I, so first of all, let's say we try to reconstruct this. We said that the last thing has to be E, right? That's what we said. The next one, in order to make this 1, I need to make sure that the word satellite shows up. I'm not necessarily going with 6 S's at the front because this will be a different thing that will show up. So if I put a T here and then another E here, would that somehow help me? Getting close to past time. Let's see if we can wrap this up. If I have E and a T, if there's a T here, that's gonna mess up because that'll match and then. What I want here is 6 and 1. Let's say I want 5 and 1, then 4 and 1, and then 3 and 1. What's wrong with this?
the one below it always has to be greater than or equal to it because of the recurrence.
Sorry, say that again?
The one below it has to be greater than or equal to because of that recurrence.
Right, correct.
So that's one
These
constraint.
numbers have to be bigger.
You cannot have a 1 and then below it a 6. Has to be a, actually no, never mind.
No, now
First-
our recurrence is going well, both these terms have Ci minus one j, that's the same row that's right above it. And it has to increase, not decrease. Well,
No, I thought it was decreasing, but this is fine.
yeah. Okay. So it's okay for this to be six.
Yeah. The other constraint is when you have like one that's a diagonal, for
Yeah.
like an E, you have to have a second diagonal in that row.
I know, but that second diagonal will show up somewhere here, right? Somewhere there. And it's,
I'm not saying this is messing up this, I'm just saying these are constraints.
I know, yeah, agreed. Anyways, all I was saying was that I tried in this direction and failed. Maybe we can talk about this more. All right, let's stop here.
So this was one of the hard ones, right?
This was the hardest from last year, second hardest from last year.
This is from last year's competition,
Yeah.
from ICPC.
Yeah.